right, we're going to take a look at how rational exponents and radicals are related. By the word rational, we mean fractional. Rational numbers can always be written as fractions, so keep that in mind there. And let's start with, if you would plug into your calculator, 9 to the 1/2. And before you plug it in, maybe kind of consider, what do you think 9 to the 1/2 would equal? And now go ahead and plug it into your calculator, and it should give you an answer of 3. Okay. What's another way to write doing something to 9 to get you 3? What's another way to do that that might be the same as this first way? Doing something to 9 to get you 3. Well, subtraction, we could go 9 minus 6 is 3, but that's not what we were looking for there. Multiplication, we're not looking for that. What we're looking for is the square root of 9. And so 9 to the 1/2 is the same thing as the square root of 9. Now, for our purposes right now, I'm going to put in a little 2, meaning square root. Square root of 9. You don't usually see that 2, but if you had a cube root, you'd see a 3. So just know when you have a root, it's always considered a square root unless there's a number in there. So what I'd like to do now is take a look at these two expressions and use some exponent rules to prove to you that one expression is the same exact thing as the other expression. So let's start with, what if we squared both sides? I'm going to write 9 to the 1/2 squared equals the square root of 9 squared. Okay, so let's see, let's talk about this first one. If we square root 9, we get 3, right? And then we square that, we're back to 9, so it just equals 9. And over here, a power of a power, this is the power rule, we have to times these together. 2 times 1/2, so this is 9 to the 1 here, so 9 equals 9. So by squaring both of these, we can see that, yes, indeed, the first expression is equal to the second expression. So let's write it maybe a more a general form of that. X to the 1 over a equals the a root of x. Let's just try this. Let's go x to the 1/4. X to the 1/4, that equals the 4 root of x. And if you wanted to do this without the variable, we could plug in a number that might work good. Let's go 16. 16 to the 1/4 equals the 4 root of 16. Okay. And let's just talk about this for a minute. What number, this 4 root is saying, what number multiplied by itself 4 times gives you 16? It's got to be a small number, and if you said 2, you're right. Okay, so 16 to the 1/4 is equal to 2. So it takes, to get 16, it takes 2 times 2 times 2 times 2. And we want to take one of those, so it's to the 1/4. Okay, here's an interesting question for you. What's 16 to the 3/4 going to be? So we want to take this much of it this time. So what's 16 to the 3/4? If you said 8, you're on the right track. Okay. So let's practice. Let's practice some converting. Let's go x to the 2/3. So we put an x here. What goes out right in the index here? What's the root? It's the cube root, so you put cube root right there and squared there. So the 2, the numerator, becomes the exponent. The denominator becomes the root. Let's try another one. 64 to the 2/3. That equals Here we have 64. What are we going to put right here? If you said 3, you're right. And then squared there. 64 to the 2/3. Let's see if we can figure that out. The cube root of 64. What number times itself 3 times is 64? Well, if you said 4 times 4 times 4, you're right. And now we're taking 2/3 of those 4s. So we're taking this much. So 4 times 4 is 16. The cube root of 64 squared is 16. Hopefully this is starting to make a little sense to you. Okay, so we started with a rational exponent, and we went to a radical. Let's do a radical this time. Let's go 32. Let's go the 5 root of 32 squared. So that's going to be 32 to the what? 32 to the 2/5. Okay. So does 32 does it break down evenly? I've been giving you all problems that break down pretty nicely. So 32 to the 1/5 is going to be 2, because 2 times 2 times 2 times 2 times 2 equals 32. So that's 32 to the 1/5. What's 32 to the 2/5 going to be? 2 times 2 is 4, so it should be 4. Now if you plug this in your calculator, if you saw it like this, one advantage to converting it over is it's fairly easy to plug it in like this in your calculator. And I want to show you how to do that on maybe a fresh sheet here. So we got 32 to the 2/5. So we're going to put caret key. And this is the wrong way to do it, 2 divided by 5. This is the wrong way to do it. What this is saying is 32 squared divided by 5. It looks kind of like this. Okay, we do not want to do it that way. So we want to try 32 caret key parentheses 2/5. Then it works. And the answer should be 4. Plug that in your calculator and see if it works. So advantage to writing it as a rational exponent, it's easy to plug into your calculator. Radical exponents not always so or radical expressions not always so easy. Okay, the advantage to a radical expression. There's the cube root of 1,000. This is kind of telling me, this is reminding me what number multiplied by itself 3 times equals 1,000. What number multiplied by itself 3 times equals 1,000? And the answer is 10. If that's telling you that, it's kind of easy to see. Some of you may be able to see that this way. What number multiplied by itself 3 times is 1,000? That would be 10. Okay, so it kind of depends on which way is easiest for you to see. For me, this rational or radical helps me say what number multiplied by itself this many times equals that. Okay, I think there's one more thing we need to cover on this, and then we will be good. So let's look at one last thing. If you have and this is just let's put -3 to the 2, I'm sorry, let's try this. -27 to the 2/3. Okay, so the negative is kind of the thing here that's kind of a little different. Okay, so -27, we could say that's the cube root of -27 squared, like that. And if you break this down, it's -3 times -3 times -3. And we square it, so we'd have 2 of them. It would be 9, be positive 9 there. Okay, or -3 times -3. Let's take a look at another one. -16 to the 3/4.